looking at the concept of the future and people thinking about, well, when we are here, what's the next step? And once we have those next steps, we need to make them accessible to everyone. So this is the Future of Architecture series, Making AI Accessible, a CYBID webinar. So you're probably here today because you might have heard about artificial intelligence becoming this disruptive force in the world. But why now? In fact, artificial intelligence has been around for a very, very long time, probably since the 50s, but even before that, the concept of automation, the concept of something being alive, it's been around for a long time. People have been speculating about it and writing books about it and fantasizing about it, but it's here now. And it's actually a really exciting time to be alive. But why is it that it's such a big deal as of last year? So this is when we're going to talk about generative and statistical artificial intelligence. This portion of my talk is going to be a little bit, just very, very tiny bit technical, very little bit, just so that you can understand where it's going. As you can see in my image on the screen here, you can see on the left-hand side, we have a little bit of a free-flowing diagram. And on the right-hand side, you can see a little bit more of a structured logic, something that looks almost mechanical. Now, we generally associate things that are free-flowing in form to be creative, organic, artistic to some degree. And on the right-hand side, what you would probably think of is something that's quite logical, structured, very easily able to follow the sequence of events. If I had to tell you, just on a very basic level, that statistical artificial intelligence would be the right-hand side of the image, and the left-hand side of the image would be generative artificial intelligence. And that's really important for you to take note of. Now, we're going to be discussing these two types of artificial intelligence not very long from now. Just so you know, at the bottom of every slide, these slides will be made available to you. At the bottom of every slide is a link to an article you can read about, which will give you a little bit more context on what I'm talking about. Now, if you have a look at the image on my screen here, you will see that you are looking at a data center. In fact, it's a whole lot of servers that are stacked on each other that almost look as though that they are like they're continuing into infinity towards you. This data center that you're having a look at is actually one of the reasons why we have this massive explosion in artificial intelligence, because artificial intelligence is about data. The more data that we can store, the greater the volumes, the better for us. Now, the interesting thing about data is that if you are able to examine it, if you are able to look at data, if you're able to dissect it, if you're able to group it, you can predict patterns. You'll see there are patterns emerging and use that as a tool to predict the future. It's very much like mathematics. In fact, it is mathematics. So you will see if you are reading up on artificial intelligence that there is a classical statistical version of artificial intelligence. And that's the artificial intelligence that we've all been used to when it comes to auto-predictive text or recommending to you on YouTube, perhaps what's the next video that you should watch, so on and so forth. These are quite standard models. And what you'll see on this image on the screen is what is traditionally known in statistics as the k-means method. Now, I'm not going to explain to great detail, but as you can see, when the image starts off, everything is green, or all the dots are green. And you have two x's or 2 points moving towards those dots. Notice that when the blue x starts to touch some of the dots that it's near, they all turn blue. And notice on the left-hand side, the same is true, but for red. Now, what you're looking at here is a method of clustering data. This is a scatter plot. It's a type of diagram. It's a type of way to show data visually represented. And once you are able to cluster data together, you're able to group it and say, okay, in this area, we believe that if such and such occurs, this is what the consequence will be. We can now start making deductions. This is statistics that you're looking at. This is a type of statistics, and it's actually part of machine learning. Now, we'll talk about the words artificial intelligence, machine learning interchangeably now and then, but I want you just to note that these are two very different things, or at least part of the same conversation. Artificial intelligence is the entire broad umbrella. Inside that, you have machine learning, teaching the machine, or machine learning on its own, identifying patterns, what you might call unsupervised learning. And then within that, you have deep learning, which consists of neural networks, which is what we'll be discussing not too long from now. But as you can see on the image on my screen here, and you're like, oh, Akheel, you lost me already. No, hang on, it's not a nucleus yet. What you're seeing here is interactions between people on Twitter. It's just represented as data. And you can see that there are circles of varying sizes and lines coming out of them. And the lines are suggesting that it's tweets, which mention another user, and the circles suggest the number of tweets and retweets sent by the user themselves. Now, I don't want you to try to cross-examine this particular diagram. What I want you to do is notice that this is a lot of data. Like we had data here on the slide before us, here's a little bit more data. In fact, it's so much of data that we can make really good predictions from it. The principle is the more data you have, at least the more honest data you have, the more accurate your predictions will be. Now, what you're looking at here is what you and I are doing every single day when we are on social media. Around about 2012, maybe say the 2010s, 2011, 2012, when everyone or a lot of the world got access to social media, especially through our phones, we were able to generate a lot of content. We started to input a lot of information to the internet. And if we can find patterns between this information, we can model behavior about ourselves based on it. So someone can recommend to you what's the next YouTube video to watch because you've been interacting with the internet so many times that it kind of forms a model of you. The same thing when you look at when you're trying to purchase something, you see, oh, hey, these are all the products I wanted to buy. In fact, you know what, I just sneezed the other day. Here's medicine advertised on the TV. It's because it's picking up patterns. And yes, maybe it's listening to you at some stage, it's your phone, but stay with me. Now that this has happened, we have enough data to make the kind of predictions and analyses that allow us to have very accurate models of reality. And this is where the concept of neural networks has come in. So let's recap very quickly, because this is the first segment. There's a lot of data in the world from data centers, which are storing them. We can take this data and analyze it and group it, cluster it, and then make deductions based on it. And all of us are contributing every single day through social media and through our engagement with the internet towards creating more information to create models about reality. And when I say models about reality, I'm meaning someone is imagining what your life is like. You can sort of predict what your life is going to be like. And if we have enough data, you can make a very accurate assumption about someone or something or what they're going to do. Now, what I showed you before the slide is typical statistical analysis. What you're seeing here is something different. What you're seeing on the screen is I'm touching a picture of a dog. It's running through what you might call nodes in a neural network, coming from the idea of how a brain works, cognitive science. And it is a computer trying to emulate our thinking patterns by joining up different bits of information together to finally put an output and say, oh, that's a dog that I'm seeing. This is generative adversarial networks, GANs, G-A-N-S, GANs, generative adversarial networks. So what's happening here is that we have a new way to interpret the data. We didn't just base it on our mathematical formulae of statistical analysis. Now we have new formulae that's based on this kind of logic called neural networks to allow us to determine information. What they've done is they have modeled an interpretation of data based on the way our brains think. And you're like, wow, why didn't they do that before? Well, it's because we just didn't have enough data to see if these experiments were actually going to work. They actually did try these things before, and it didn't work because you didn't have enough data. Now we have a lot of data. And so that moves us onto the final slide of the segment, which is ChatGPT. If you look at the article at the bottom, one of the pioneers of the large language model movement, or at least artificial intelligence the way we know it, a large language model is the category under which ChatGPT falls. ChatGPT is a large language model. What it's done is it's taken large language, meaning lots of information, lots of data about a language, and it's been able to create a model of that. So we can simulate, we can speak, we can use it in a way that is like the way we talk. They call that NLP, natural language processing. So it's like when we talk to the computer, does it understand us? We don't have to type in Python, we don't have to type in JavaScript, we don't have to know any programming or coding skills. Essentially what ChatGPT is doing, it's taking the best of statistical artificial intelligence and marrying it with generative artificial intelligence, which is where GANs come from, generative adversarial networks. It's a type of neural network. It's married the two together, and what it's essentially doing is, like on your phone when you type in on WhatsApp and you're saying, what's the next word? saying I, and then it comes up, pops up there, you tap it, say, what's the next word? Going, what's the next word? Home. This prediction, it's trying to tell you what's the next likely word. That's normal statistics. But what generative adversarial networks do is it kind of creates randomness in the next answer that it will give you. So instead of saying, I am going home, it'll tell you, I am going to the barbershop, I am going to work, I am going to so on and so forth. By using this creativity, if you could call it, it starts to create something that resembles a human conversation. And that's actually what's happening in ChatGPT. It's really just predicting what's the next word and using some randomness to make it sound a little bit more human. But that's an oversimplification of the process. Because what I might be describing to you is the concept of intelligence, really. Now, I'm going to give you some insights. Today, we're going to look at 5 insights into artificial intelligence and how we can use those insights to understand what it's about and how we can use those insights to digest what's going on. Let's ask the question, because it's an important one to ask. What is intelligence? And the part you should note to yourself there is utility. So intelligence in itself, a general definition, isn't knowing things, but it's really knowing when to apply what. It's almost as though it's an ability inherent in ourselves. That's intelligence. It's us being able to do something based on whatever information we have available to us. It's knowing the appropriate things to do or say in the appropriate moment. It's an ability. It's something generally that you are born with. It's an ability that varies amongst all of us. Some of us have greater intelligence as a capability than others, but that doesn't mean that you are less of a person. It's just how we are. And why is that important? It's because it gives birth to the concept of utility. Utility means usefulness. We can do useful things because we are intelligent. Now, that idea that I just mentioned to you is something that is discussed quite widely, and there's no actual, I would say, consensus on the agreement of a definition for intelligence. But what I'm telling you here is probably the most helpful way to look at the word intelligence when it comes to artificial intelligence. It's usefulness. So who you're looking at the screen here is Ilya Sutskever. He is the co-founder of OpenAI, well, one of the co-founders, and you would have known that there's a lot of drama going on these last few days with OpenAI. OpenAI, the company that's responsible for creating ChatGPT, he is one of the lead data scientists who was able to get ChatGPT going by using neural networks. What Ilya said about 1 day ago, say 2 years ago, he mentioned that the reason why he pursued artificial intelligence was not because of technology itself, but it was because he was trying to understand what it meant to be a human. And that's a fundamentally important concept. You know, the technologies we create are to some degree extensions of ourselves and reflections of ourselves. He stated in his TED talk that he did that what he actually was trying to do is figure out this concept of consciousness. So it obviously pushed him in directions to pursue artificial intelligence. How he sort of defines artificial intelligence, he says it in this really interesting way. He says that the biological brain is what we have as humans, but the electronic brain is what artificial intelligence is to computers. And so what he's trying to say is that there's a digital brain for computers, which is artificial intelligence, and that there's a biological brain for us, which is our brain itself. So talking about the brain is a pretty interesting concept. Let's talk about that very quickly. As you can see on the screen in front of you, you can see there's on the left-hand side the concept of intelligence, and on the right-hand side the concept of knowledgeability. Here's the ways we're going to look at these. Intelligence, as I mentioned to you, is almost something like the ability to adapt to different situations. It's an ability within you. Whereas knowledgeability, on the other hand, is the storage of information. How much do you know? Because you could know a lot of things about a particular subject, but you might not know when it's appropriate to apply it. Intelligence helps you use knowledgeability correctly. Intelligence and knowledgeability are interconnected with each other. Where intelligence is more about reasoning, knowledgeability is about the storage of information. And so these two are interconnected and depend on each other. You can't have one without the other. Because if intelligence is the ability to make decisions based on knowledge, if you have no knowledge, you can't make a decision. Vice versa, if you have a whole lot of knowledge without intelligence, you will not know when to apply this knowledge at the appropriate time. So these two concepts, intelligence and knowledgeability, are quite fundamental. It's because of these two concepts that we have to now question what do we actually think real or human or natural intelligence is. It's because a human can do these, but so can a machine. A machine can so-called reason, and in fact, you've seen it quite well. You've been using, for most of you, calculators from the time you were in school. You might remember there was even a log book before. But the computer and the calculator, they can add much larger digits much quicker than you and I could do. Likewise, a computer can store information, a lot more information than you and I can. And so these two concepts now from a computer can rival our abilities. I don't think this is something that you would necessarily dispute. But what a computer doesn't have is the combination of the two, which is then a factor of time. So if you have intelligence, the ability to reason, and you have knowledgeability, a lot of facts stored, information stored in your head, you then add the concept of time to it, or the factor of time, meaning you have this ability and this knowledge over a period of time, you then become wise. Wise means you now not only know lots of information and when to apply it, but you are seasoned enough through the realities of the world to realize it's not just about knowing when to do what, but it's also about how people feel. It's also about ethics. It's also about knowing that there's a much larger system. Whereas an intelligent person might do something to relieve the immediate problems. A wise person will not only relieve the immediate problems, but also make provision for the future because they understand what will be coming. That's wisdom, and that machines cannot do yet. So a very good way to look at this is a lot of people try to assimilate intelligence to practicality, and they assimilate knowledgeability to theoretical nature. They say if you know a lot of stuff, you're very theoretical, and if you are capable of doing things, you're very practical. And then hence our debate, theory or practical, one or the other. But it's not necessarily that you need one or the other. You need both of them and the appropriate time to use them. Like I said, wisdom, on the other hand, is the combination of both. But talking about wisdom, when we talk about being wise, we often refer to wisdom as, well, when do you know what to do, when to do it, who to maybe affect and not affect. And this gives us, or gives birth to the idea that, you know what, I need to really consider systems. I need to think from a systemic approach, systems thinking. That's wisdom in itself. Hey, there's a maturity about it. A systemic approach is what economies do. Economies are really the consequence of our decisions that we make every day that have financial implications. Okay? That's an economy. It's the little decisions we do every day that affect money or the transfer of things in this world. What's important that technology brings to us now is the concept of abundance. Now, before I lose you, let's recap very quickly. We spoke about intelligence and utility, and I said that intelligence is a form of practicality. That's generally what it is. You can solve a specific problem right now, immediately. You'll know how to do it very well. We mentioned that Ilya Sutskever, one of the co-founders, spoke about, well, you know what, it's this intelligence concept is really a lot like our brains and how our brains function. So let's apply that and see where we get to. And then we said, okay, there's intelligence and knowledgeability. Well, those two need to go together, but ultimately we are wise. Human beings are wise. We need to aim for that kind of wisdom in ourselves to maybe differentiate between us and the machines, if that's your premise. But let's now move on. We spoke about this concept of being wise. It is wise, and I would think it's very wise of anyone in the field right now to understand that we are not in a very good economic position. Architecture in itself is actually struggling as a field. And I know there's a number of students here. I just want to make it evident to you that your earning potential is greatly dependent on the skill set that you have in architecture. It's not a very good one, nor a prosperous one, if you are going to limit your skill sets. Economics is a fundamental part of social justice as well. You cannot have an equitable society where there is an inequitable distribution of resources. And so this concept of trying to have a better economic life leading to better economic prosperity is also linked to the concept of social justice, which is actually, to some degree, what the concept of artificial intelligence is based on. It's trying to create an intelligence or intelligences for all of humanity to use, to benefit us. That's a social problem. Economies of scale is something we're talking about, because as soon as we now can have the concept of economy in it, we talk about abundance. I'm going to talk about three things here: abundance of data, time, and resources. Now, I know you might be losing me a bit. Hold on. I know it's the afternoon. We're going to get there shortly. You might know this image here as the silicon chip. The silicon chip that you're looking at is actually one of the major turning points in history which gave birth to the modern computer. And what you might know about the silicon chip is that there is Moore's law. Moore, the person that founded Intel, or co-founder of Intel, and also I think he was a co-founder of Fairchild Semiconductors, the guy who had been creating computers before Apple was the thing, and Microsoft. His prediction in Moore's law was that the number of transistors is going to increase and the cost of it is going to decrease as the years go through. And this has actually been proven to be true. And maybe it's decreasing a bit now. The law is maybe filtering out, fizzing out a bit now. But more or less what he's saying is quite true. Moore's law is suggesting that as the number of transistors increase, transistors, these little things on a circuit, which allow it to store more information, as those numbers increase and they get smaller, there's going to be an abundance of it, and therefore it will be cheaper. And so if there's an abundance of something, it can be cheaper. It means more people can have access to it. And this is quite true for the computer. In the 60s, not everyone had access to a computer. But now, because we have these really tiny computers, very little resources taken to make a computer of a silicon or from silicon, we can now have more computers everywhere. So the concept of abundance or optimization really is what we're talking about here, is something that artificial intelligence can give us. But what about the optimization of time? If I were to talk to you and tell you, well, you know, imagine if I could tell you the most productive way to use your day, where you spend the least amount of time but get the maximum amount of gain. You'd be very open to that idea. And in fact, in a capitalist society, that's the game. That's mainly what a factory wants: the least amount of resources to create the most amount of product. That's what everybody's aiming for. But the question now is, well, if I could optimize everything, what do I do after that? Imagine if I've optimized my system so much that to create an entire building only takes me 5 minutes, with its working drawings, with everything, sending it to the client and renders it. If it only takes me 5 minutes, and that's how long it takes me to do my work now, because artificial intelligence has helped me to do it so quickly, then what else do I do with my life? What is the purpose of my life anymore? Now we have some existential crises, and I don't think this is a difficult argument for anyone to see. It's actually quite an obvious one. But I want you just to take note right now. We'll get to that question not too long from now. What I want you to take note of is the concept of time being used at a minimum to gain maximum benefit. Again, that's the same concept of abundance and optimization. But what if you could do the same thing to the built environment around us, or sorry, the natural environment around us? What if we could figure out a way to use so little of its resources that whatever is left on this earth actually seems abundant to us because we are using so little of it? Or we find a way to use it so constructively in a manner that we just perpetuate cycles, keep recycling, that we never ever run out of resources. This would be the ultimate goal of sustainability, the concept that there is an abundance of everything if we know how to use it correctly. So this concept of artificial intelligence, it allows us to try to figure out how to optimize things, optimize the use of resources, optimize the use of time, and even help us in being able to make better computers that consume less power and electricity. So that's a recap on this part, and let's move on to the next portion. I hope you're still following. If you're not following, close your eyes a little bit. We're getting back into it. The next one is not so heavy to digest. We're talking about resources. Now let's talk about creativity, because creativity can maybe be seen as a form of resourcefulness. You're like, oh, Akheel, I'm trying to simplify my whole life here. I'm creative. I was born creative, and now you're suddenly reducing me to just being resourceful? Well, let's see about that. You might know this film, I, Robot. You can see Will Smith there before the slap, talking about, can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece? And then, like the Thug Life, the machine says, can you? And you see his indifferent face. Okay? So this is kind of the argument everyone has currently. It's like, yeah, but it can never really truly be creative. I agree. I don't think a machine could necessarily truly be creative. But if you had to look at this picture here that I'm showing you, I think you might to some degree agree with me that this is a creative endeavor. This is a piece of artwork called Machine Hallucinations, using artificial intelligence to create a piece of artwork by Rafik Anadol. It is what you might call a digital artwork, digital art piece, but there's artistry in it, and it's using artificial intelligence to create it. And so I want you to think a little bit deeper as well about the concept of being creative. What's actually happening here, if you have a look at these images I showed you, you just saw it just now, all of these images are generated by artificial intelligence. There's nothing here that I've created or a graphic designer's created. It's all from artificial intelligence. I would say that this is kind of creative in its pursuit. Look at how well it blended some colors together, and it tried to convey the concept of intelligence and knowledgeability with the owl there. I didn't ask it to do that. It's using things that we generally ascribe to knowledgeability and intelligence, and it's showing that image. And then on the right-hand side with wisdom and empathy, you can see as soon as you bring color into it, you're kind of showing the diverse representation of people. And then at the bottom right, time, look at how all of those lines flow into each other. Now, this is creative pursuits. I didn't do this. I just typed some words and it created it. What the machine is doing, this one that we are criticizing here, is that it is taking whatever is available to it and joining it in unconventional, unique ways to create something that has never been seen before. This is what generative AI does. It takes really strange concepts that we wouldn't have thought it might use and bring it together to form something new. And now this is when I ask you, what if a machine could create something so unique that you couldn't identify if it's unique or not anymore, if it's original? Because remember, it's dealing with billions and billions and billions of data sets. As I showed you here in the beginning, this information that the machine is processing, this is billions of data sets or billions of bits of data. You cannot know or comprehend even how large that number is. And so there's information here that when strung in a particular way is very likely to give birth to something so creative, you might not be able to recognize it. So then I ask you, if you are unable to identify originality, then how will you know whether a machine is creative or not? How will you know the difference between originality when you cannot tell the difference anymore? And that's not a difficult thing or a far-fetched question. It's actually what is kind of happening now. And so let's take that a little bit further. How can that be helpful to us? The images you see on my screen are images I created in 2022 when Midjourney became quite a popular software. It is actually at the very early stages. I was amongst the first few people to use them. And what you're seeing here is myself entering very different concepts: South African architecture and parliament, and the idea that if South Africa was not colonized, what would that kind of look like? So what we're doing here is we're trying to imagine, hey, what could we do if we simulate environments? What could have been? In fact, it helps us and saves us the time of going through the painstaking process of imagining this stuff and seeing what it could look like. These images are generated by Midjourney. It's trying to create a South African parliament buildings using the concept of African drums as a fundamental core of the design process. It's generated it without much help from me. And so what I want you to take note of is, currently in South Africa, we have a problem. Our problem is we are scarred by the events of apartheid and years of colonialism and the bad consequences of it. And so if we had to try to imagine, well, what could an architecture be like if it was allowed to naturally develop in South Africa? Now, what if we could do the same with the Indian continent or the South American continent or the African continent? What would happen if we could imagine if colonization didn't happen and all of these wrongs of the past or all of these things that might be seen as scars in history didn't happen? What could that be? We might be able to find a uniquely South African identity. Again, I'm not saying we don't have good architecture in South Africa. I'm saying we don't have anything that has been from first principles derived to be South African architecture. We really are an amalgamation of the international style. And people have tried to do this. And if you see this image, you might recognize that this is Wakanda. And what you might realize in Wakanda is that they tried to achieve the very same thing. Now, it's very easy for me to criticize and say, well, it's not really African architecture. This just looks like Dubai with some greenwashing over it. Could do that, but they actually tried. they tried to see what could an architecture be like if the continent wasn't colonized. We could now get closer to answering that and creating a unique South African identity, as opposed to taking what the British or the Dutch or whoever it was that's been here and reinforcing concepts that aren't actually grown from our home soil. Because remember, British architecture was grown on British soil. It was a result of the context of what happened in Britain. So it's very appropriate and specific for Britain. And Dutch architecture is also very appropriate and specific for the Dutch because it's from their land. It's for the people there, for the natural conditions, for everything that has occurred. Now, when you import a style of architecture into a place, you're not really using the context of the place, you're just importing ideas. What if we could imagine what a real South African architecture could be like? So talking about this and identity, who owns what? We have about 2 segments left in my insight. We'll be done in the next few minutes time, TD. I hope I'm okay on time still, but I'm going to pursue till I finish this. So peeps, if you have a look at my screen here, I'm asking the question is, who owns what? That's a concept of endowment, right? Endowment of rights and responsibilities. Since I started off with Will Smith almost smacking the robot there, I'm going to continue with it and say, well, what we're looking at here is a machine trying to draw. And this is from the movie I, Robot. And what it's drawing is, as you might recall, if you did watch the movie, it's drawing a dream that it had. What? Can machines dream? Now, the question of sentience or being alive, is it conscious? That's one that's going to be very difficult to answer because we don't even have a really good way to measure our own consciousness at this moment. But if you just have a look at the image that's here, what you can notice is, well, if a machine could dream, what if we created something that was so unique, it seems to have its own identity, and maybe, hey, a personality, then something's really difficult for us to distinguish now. Maybe it is alive. And that comes to the philosophical questions as discussed by one of my favorite YouTube channels, Crash Course, where they talk about the concept of personhood and endowment for artificial intelligence. Now, it's not like we are the first people to think about this problem. This problem has existed for as long as we've had computers and probably for as long as we've been building things. We ask ourselves, are the things we build alive? Are the trees alive? Does it have consciousness? Does it have a level of consciousness maybe that's so low we can't perceive it? So what Alan Turing, who is known to be perhaps the father of the computer, he discussed philosophically the idea that, you know what, we could test a computer to see if it is alive. Just in summary, I'm not going to explain the entire thing. It's if it can produce something like us or give us an answer that's convincing enough that we cannot distinguish, maybe potentially it is alive. Now, that's an oversimplification of the argument, and maybe I'm not being entirely accurate. I'm just trying to give you the idea that he has a test to determine it. It's called the Turing test. There's other views as well, like the Chinese room. It's another test to determine life and consciousness. These tests do exist, and they try to help us determine what happens if we can no longer distinguish between what is created and who is the creator of the created. And so here we have to ask ourselves the following questions. Now, I call these levels of depth or levels of thinking. And what I'm trying to get at here is the more superficial you're thinking about artificial intelligence, the more likely it is that you will only find a solution in the short term, and that in the long term, you might very likely become irrelevant. The less time you spend thinking about these things, the more likely it is that you might be affected by the rapid pace of technological advancement, meaning you won't be able to keep up with it. The longer you think and the deeper you think about these things, the more likely it is you will be able to future-proof yourself. So in these levels of depth that I'm talking about here are some of the questions you should ask yourself. What happens if everything is optimized? What does that mean for myself? If I don't have to design a building and take 10 days or 2 months to do it, or 3 months to do working drawings, what else could I do in this time? What happens? Now you can be creative, so-called creative with yourself. What else can a human being do? What if money isn't a problem anymore, like the universal basic income that OpenAI is talking about? What happens? And I'm like, yeah, Akheel, you're being a dreamer. I'm not being a dreamer. I'm trying to consider all the possible outcomes. Let's move a little bit step further, because I'm sure you've asked yourself that. What happens if I cannot identify originality? The same problem we had just now. Something original this machine has came up with, it's maybe dreamt it. What happens if you can't identify it? Okay, cool. Great, you created this new GPT. It created a piece of artwork. It's trained to be you, but it created something brand new and you can't identify it. It doesn't look like anything you've ever created before. who does that belong to? And you're like, oh, that's a simple one. It belongs to the machine. Or, hey, it belongs to me. I created that thing. Well, okay. Then who should get paid for the work if the machine created something that was so original and so unique that it can't be ascribed to you? Should you be paid for creating this type of artificial intelligence, or should we pay the artificial intelligence? Or what happens if something the artificial intelligence creates, which was not part of your programming, but somehow we create something that's harmful to society? Should the machine take responsibility? And the easy answer is like, no, man, a person should take responsibility. Or if you had actually nothing to do with it. How much of accountability should you take if something like that goes wrong? You created this thing, you were happy with it for a long time, suddenly it starts sending blackmail to people and starts sending things that are hurtful. Should you take responsibility for it? Who's the one that should stop it now? Is it autonomous? So these kind of questions I ask you because these are things you should consider. And it's not like I have answers for it. Like, I'm sure everyone must be waiting for me to give an answer. I don't have an answer to it. Unfortunately, I would have loved to, but I don't. And this is why we need a collective intelligence, people reasoning with it. Because the longer persons like yourself and myself who aren't from an artificial intelligence background, who don't have a background in, say, this new type of artificial intelligence, the longer we stay away from it, the more we are giving our responsibility over to others to make decisions for us. This is not a people who are the data scientists problem. This is everyone's problem because it's going to be dealing with all of our lives. So let's now go to the final segment here on who is the future. We spoke about a number of things now. We spoke about the concept of intelligence and utility. We spoke about the concept of economies of scale and abundance. We spoke about endowment. Should we give rights? And just by the way, on this final one, you know that a business can be seen as a legal entity. Maybe we should see AI as legal entities. Just like in some countries where the environment has rights about itself and rights for protection for itself, and people represent it, maybe that's what we should do for AI. I don't know. So in the last bit here that I'm looking at, who is the future? We talk about accessibility now, which I started with in the beginning. Who is the future? Well, it's anyone really that's listening to this conversation now. The person here that's standing in the picture that's staring at the Fourth Industrial Revolution and what looks like the Union buildings there, it could be anybody. It's someone, you or me, that's willing to now contribute to this massive discussion. Artificial intelligence allows us this kind of intelligence that can help us solve problems. Students who are here, you should take on bigger problems because before, if you thought you were unable to find solutions, you can find solutions now. There is an intelligence, something like a friend almost, if you can think about it that way. I'm not saying you should, but I'm saying if you consider it that way, maybe it can help you solve the fees must fall movement problems. A number of things that students are experiencing, maybe it could help you. Or if it's yourself who's a professional trying to stop pollution of the environment, artificial intelligence as a software, as even if it's just someone to talk to, can help you reason through your own ideas to figure out what's the solution to it. Or if we use software that can help you optimize processes, we might not need to pollute the environment that much. Or we could figure out ways to solve climate change. In fact, they call these the large problems or the wicked problems of the world. What are these massive global problems that exist in the world? And we can now have an intelligence that can help us solve it. It's not about learning artificial intelligence. It's maybe more about knowing when is it best to practically apply it. Because we could now maybe use it to solve some of our major problems. How do we reduce CO2 emissions if that is what is causing climate change? Or how do we ensure that we are prudent towards our environment? How could we create something that is tornado resistant? This is what the AI does. It uses the collective intelligence of whatever's been dumped on the internet and some sort of reasoning to figure out solutions for us. Or what if it's you trying to figure out how to protect that kangaroo or that kangaroo's habitat? What if you could figure out an architecture that is properly regenerative, but you didn't study it on campus? You maybe studied it, you maybe just studied passive design principles, but now there's an AI that can help you design something that's regenerative, that restores the environment. Or what about the wastage of food? The thing with AI is not that you need to learn to program so much, although I do recommend it. It's about knowing how to use it to solve some of the world's biggest problems. It allows us to be bolder than we've ever been before. So here are the summary of the concepts I discussed today. These are the 5, I think, that are insights into AI, which people aren't really discussing as much as I would like them to. If we did this, I think we'd be able to have more robust discussions on it. Utility is a really good concept because it's like intelligence. It's making AI useful for us. The concept of abundance is optimizing as much as you can time and resources. Resourcefulness is another way of looking at creativity, using what you have in unique ways to create something exceptionally original, or what appears to be original. Then should we consider AI as people? That's a real thing, because if they act and behave like us and do things that seem just like us, what are they? And then accessibility, it's all our responsibility, because OpenAI, for example, has made AI accessible to everyone. So that's the conclusion of my presentation right now. There's other things I need to mention, or I'd like to mention towards the end, but I think I've gone far over my time. Apologies for that, but I think this was part of the information that might not be so readily accessible to everyone. I'm going to hand over back to you, Tsidi, so that the students can go.